And good morning, sixth graders. Today is lesson 4, and we are learning about infinite and finite sets of numbers. Do you guys know what the word infinite means? Do you guys know what the word finite means? Well, once we know the definition of those words, we will be able to figure out what sets of numbers are either infinite or finite. All right, so let's go ahead and let's get into our lesson, top of page 16. Let's start reading. Some sets of numbers are infinite. They continue on without end. The counting numbers are infinite. We can start with the number 1 and never run out of numbers to count. So if we would sit here, we go 1, 2, 3, 4, 5, 6, 7,286, 7,287, 7,288, 7,289, 1,476,223. You guys get the picture. All right, so we would have a infinite set of numbers that would just keep going on and on and on. We would never run out of numbers to count. To show that a set is infinite, we list the first few members of a set followed by 3 dots. So notice, if we're using our counting numbers, we're going to go 1, 2, 3, and we're going to go 1, 2, 3. That resembles our infinite set of numbers. We show the set of counting numbers this way. So notice we have 1, 2, 3, followed by 3 periods, all right? The multiples of any number are infinite. So if you notice, the next section, it says the multiples of 3, which would be 3, 6, 9, 12. Those would keep going on and on and on. There would be an infinite, that would be an infinite set of numbers, the multiple of 3. Also, the multiples of 7, which would be 7, 14, 21, would go on and on and on. The even numbers and odd numbers are both infinite sets as well. 2, 4, 6, so they go on and on and on. So, pretty much, if you have an infinite set of numbers, you're not going to run out of numbers to count, okay? It's not a set number of numbers. All right, so that's what infinite means. Let's jump into what finite means. The next paragraph. It says, sets that do not continue on forever are called finite. Each member can be listed. If the list is too long to write, you can use 3 dots in the middle of the list to show that the set continues in the same pattern between the first number, or the first part, and the last part of the list. So, if you notice, they would have multiples of 3 that are less than 10. That would be a finite set of numbers because we'd start with 3, we'd go 6, and then 9, because the multiples of 3 that are less than 10 are only 3, 6, and 9. So it's a finite set of numbers. It has a beginning and it ends. Notice that the multiples of 4, less than 100, would also be a finite set of numbers. But notice how they listed those. They went 4, 8, 12, 16, and then they went 20 yet, and then they did their 3 dots, and then they listed the last multiple of 4 that would fit under 100, which would be 96, all right? So these are both finite sets of numbers. They have a beginning number and they have an ending number, okay? So for your new part today, that's all you're doing is 1 through 6, and then you have a couple at the end of your lesson. All you guys are writing are whether your set of numbers is infinite, meaning it's going on and on and on, it has no end, or if it's finite and it is a certain set of numbers. It has a beginning number and it ends somewhere at a certain number. So let's just go ahead and let's do number 1 together. The first question asks the set of multiples of 12. So we have 12, 24, 36, 48. Notice it says the set of multiples of 12. So does that have a beginning and an end, or is that an infinite set of numbers? You should have down an infinite set of numbers, right? Because the multiples of 12 can keep going on and on and on up to a very, very large number and keep going. What about the next one? Let's do number 2. It says the set of multiples of 10 from 100 to 300. And notice how they listed that. They started at 10, and then went 20, 30, and then they did their 3 dots, and then up to 300. So is that an infinite set of numbers or a finite set of numbers? It would be a finite set of numbers, right? Because it begins at 10 and it ends at 30, all right? So that is what we're learning today, is what our infinite set of numbers and what finite set of numbers are. Let's go over it again one more time. Infinite set of numbers means it just continues on and on and on without end. Finite is a set that does not continue on for forever. Finite actually means like a fixed measure. So it's a fixed set of numbers that goes into our numbers that we're given, okay? That is all for your new part. Let's look over our We Remember. You guys have some teacher checks about a map scale on page 17. And you're gonna get your questions, for your answers for that on page 9. And that is all for our We Remember. There's no star problems, so I will see you guys tomorrow for your quiz. Don't forget to study for your quiz and for your quiz. Let me just quickly look here. Make sure you know what your area of a parallelogram is. Make sure you know how to find your missing dimension using your perimeter formula. And what I mean by that is, meaning if you're given a measurement like this, oh boy, that's really bad. Your perimeter equals 28, your width is 7, and you want to find out what your length is. Remember, we use our formula, perimeter equals 2 times our length plus 2 times our width, and then we substitute where we can to find out what our unknown value for length is going to be. So make sure you know how to do those. Make sure you know how to use map scales, and make sure you know how to add and subtract your mixed measures. Make sure you know how to translate numbers into, translate a math sentence into numbers and symbols, and all that good stuff. All right, study hard, and I will see you guys hopefully tomorrow for your quiz. Have a fantastic day, and I will see you guys later.